first climb. But cranes stand like gallows against skies painted blue. As mountain clouds drift in their slow-moving view. Shadows grow heavy like thick pools of tar, hiding the scars where the new buildings are. Sliding some ruins we left out of sight to watch how the city devours the light. Oh, the tower gleamed bright like a tooth in the sun. The race for the kingdom has only begun. The roots twist and rise, breaking tiles below. The ledge is still hides an old smile we know. Yes, sunlight burns glass till it shines like a gem. Pools of tar, hiding the stars where new buildings are. Sliding from ruins we left out of sight to watch how the city devours the light. Oh, a tower gleams bright like a tooth in the sun. The race for the kingdom has only begun. The roots twist and ride, breaking tiles below. The ledge still hides an old smile we know. Yes, sunlight burns west till it shines like a tin. All the tears at the hand.
Good evening, ladies and gentlemen. Welcome to the MachinistM stream. Hope everybody's doing well tonight. So we got a bit of a busy night in terms of watching videos. Got a few things that have built up over the last couple weeks that I haven't gotten to in stream, so I'll get to them tonight. And then we will get into some gaming. Just trying to decide if I want to jump back into Pragmata, or if we will continue with Destiny 2. One I need to finish, and the other has, well, there's a long-standing itch that needs to be scratched, and that's blasting everything in sight. So, without any further ado, though, let's get to YouTube. This looks like it's the brand new trailer for Ghost in the Shell, the new one that's coming out July 7th, featuring a new music. So let's have a look. Okay, that was a little fast. I've thrown it down just a touch. Okay, but Vato psyched up to probably see something get blown up. That's kind of hilarious. I really like the Ghost in the Shell setting, largely because it's not nearly as dystopian as a lot of the other ones, like cyberpunk. is depressingly dystopian. The Ghost in the Shell, at the very least, it's just modern dystopian. It's not like all the corporations control all the food and all the business and etc. It's a bit more hopeful, but also accepting that reality isn't going to change too terribly much in terms of the average day to day. Like, yeah, everybody's wired and digital to the internet, but it's still, everybody's still living like they live today, one day at a time, one foot in front of the other. Okay, and now that we've had some fantasy, let's jump into what
Physicists believe that
Sabine Hossenfelder has to say about physicists rethinking dark matter. Honestly, I'm in the camp that thinks dark matter is bullshit, but looks like maybe there's something new. Or maybe not.
80% of the matter in the universe is dark matter that we can't see. But despite decades of trying to measure even a single one of the dark matter particles, they haven't been able to confirm that this matter really exists. In the past years,
yeah, we've spent how many years and not found nothing? It makes me a little bit suspect that maybe dark matter doesn't exist.
physicists have been rethinking the dark matter idea, but not in the way you might expect. Dark matter has made physics a laughing stock because it doesn't seem like a scientific idea. Hey, we have these observations that we don't understand. Let's just make up some invisible stuff so that the maths works out. In everyday circumstances, making up invisible stuff to explain observations you don't understand is a fast track to psychiatry.
Yeah, exactly. My point.
However, in science, it can be justified provided that the explanation is simple, because if you can calculate a lot of observable consequences from few assumptions, that's good science. And dark matter used to be such a simple, good scientific explanation. That's because for astrophysicists, dark matter doesn't just mean invisible stuff. It means very specifically something that doesn't interact with light and that's fully described by its energy density without pressure. Dark matter in its original form really only had this one parameter, the initial energy density, and then all the rest should have followed from this by the laws of gravity. Problem is that this didn't work. The observations just didn't comply, and the more observations astrophysicists gathered, the less it was working. You see, if you stick with this simple dark matter model that tells you what galaxies should look like and how they form as matter in the universe clumps. This is because there's so much more dark matter than normal matter that the dark matter totally dominates what's happening. But the predictions from the simple dark matter just don't fit to the observations. Big galaxies seem to have fewer small galaxies around them than predicted. The density in galactic cores isn't as high as predicted. Galaxies form faster than expected, and their size is correlated with the brightness, which really shouldn't be the case. There are new problems popping up each month, like this case that just doesn't want to fit the simple dark matter model. So what have astrophysicists done in response to these observations? So what have astrophysicists the brightness, which really shouldn't be the case? There are new problems popping up each month, like this case.
Possible challenge for cold and warm dark matter. How can it be warm or cold if it doesn't interact with light or heat or infrared or anything? You'd think it would just stay the same temperature, eh?
That just doesn't want to fit the simple dark matter model. So what have astrophysicists done in response to these observations? They've made the models more complicated, and they've made many of these models. This is why there are now several headlines each week about some new dark matter ideas. A new theory of dark matter could solve 3 cosmic mysteries, or could dark matter be made of black holes from a different universe? Scientists are pretty sure they found a portal to the 5th dimension, the portal being dark matter, or we still can't see dark matter, but what if we can hear it? These are all headlines about increasingly obscure and complicated dark matter models.
And a desperate scramble to fulfill the publisher die mandate that is academics at the present time.
The one big trend has been to go from one dark matter particle to an entire dark sector of multiple particles. Sometimes these are literally hundreds. The other trend has been to give the dark matter interactions. This is known as self-interacting dark matter. Just have a look at these recent archive posts with the keyword.
Holy crap. That's a lot of posts. 2,621. And each one scrambling for a little bit of academic money.
A dark sector. Primordial black holes coupled to a dark sector. A massive vector sector. Dark sector antibaryons. A massive dark photon and dark matter particles of spin up to 1. Higgs portal. Heavy neutral leptons and heavy QCD axion models. Decaying spin 3 half dark matter 2 scalar fields. An anisotropic spinor field. A sequestered dark sector. And those are just the listings from the past week.
Holy 2,000 papers in a week? Yeah, I would say there's a bunch of people scrambling for a paycheck.
Papers are all a 10 out of 10 on the bullshit meter. Oh, you might say that's unkind. And maybe it is. But this is not proper science. These are people producing papers with bullshit theories that they fumbled together so that they fit observations and can't be rolled out. It's no coincidence that this is the same nonsense theory production which happened 2 decades ago in high-energy particle physics, because people left particle physics and now do astrophysics. But it's the same damn thing. They haven't learned anything. Instead, they now complain about me when I point out they got paid for producing bullshit papers. Why am I telling you about this? It's so that you know why I don't talk about the papers that these headlines are about. They've nothing to do with reality. There's nothing interesting to find there. What astrophysicists should do is to collect all data and look for the simplest explanation that explains it systematically. We already know that this will be a combination of cold dark matter and modified gravity, but that's the path no one wants to go down. So yes,
Yeah, because those are terribly unexciting. They don't, well, they're terribly unexciting, and they probably don't conform to the dogmas of people peer reviewing their papers.
Physicists are rethinking dark matter, but the result is that now it makes even less sense. Science needs problem solvers, people like you.
And the other thing is, how many of these papers were shit out using ChatGPT, which is, or one of the other AI agents, but ChatGPT in particular is a very, I think it is gaslighty, as well as it strokes your ego in ungood ways. Never says no, never corrects you. Customer's always right, and the customer is sometimes right. A lot of times the customer's a dumbass.
If you want to turn your talent into hands-on practical knowledge, I recommend that you check out Brilliant. Brilliant offers interactive courses on topics in science, computer science, and mathematics that let you build up your knowledge systematically to true mastery. The courses adapt to each learner's background, skill level, and pace, and they constantly add new content, like this course about digital circuits that explains how computers really work. They also have super useful courses on artificial intelligence and probability and chance. The courses on Brilliant are so well done, they really click into my brain. Sounds good? I hope it does. You can try Brilliant for free.
It might click into her brain, but how does it click into the average person's brain? That is the measure of a good academic program.
For a full 30 days. And if you use my link brilliant.org/Sabine or scan the QR code, you'll get 20% off the annual premium subscription with unlimited access. Thanks for watching. See you tomorrow.
Okay, so there's that. Link in chat. Actually, I'll do this one too. Okay, jumping over to Titans of CNC. Oh, right, this is how they make a CNC machine. Ah, yeah.
Check out this casting right here. Crazy thick. Like, let's walk over here. Check out these linear guideways, 4 in a row. Boom. Look at this spindle. Like, let me get close to this spindle. Like, the spindle is massive. Usually when you take sheet metal off of a machine, it's lacking. But when it comes to YCM, they're built so tough. Like, you gotta understand, like, YCM, when we bring these machines in, they're like 30% heavier than other major brands.
Holy crap, that's impressive. You know, the stuff I've been looking at is small, but an extra 35% heavier. They ain't moving. That, on the other hand, it means you got to make sure your concrete slab is equivalently thicker.
And it's because of how they build it. Did you know that YCM has their own foundry? They make their own spindles. Like, the whole process is just on another level. And I love how Rick Chen says YCM is an engineering company because they come from mold and die. And when it comes to molds, everything has to be absolutely perfect. That's why having your own foundry actually matters, because you need to build robust, big castings.
Okay, so YCM is sounding like a vertically integrated company, and I do like me a vertically integrated company. Life goals right there.
So you can actually have the dampening, have the heaviness of it, and build from that foundation to keep incredible tolerances. So today you're in for a treat, because Rick is going to show us the entire process of building YCM machines right here in Taichung, Taiwan, baby. Let's go.
So this is where all the machine starts, is the casting. Now, of course, YCM we have our own foundry, so we make our own foundry. We have to make sure that the casting is strong and stable. So this is where it starts. So down here, you'll see some mold patterns.
He speaks very good English.
Wood patterns. That shapes the casting itself, and it goes through a shaping process here where you pour the sand into the wooden mold, take the shape of the casting itself. And behind there, we have 2 mid induction furnace. Both of them is about 6 tons. So the largest casting we make is 10 tons. What's special about casting basically is that we have 30 years of experience in casting. So apply a lot of the knowledge into the formula and ingredients of the casting to make it stronger, and also have better, more stability in the casting itself. Where you pour the melted metal into the mold itself to have the casting form. So after the casting is formed, then we take it to a vibrator to break the sand. And from there, we go to a annealing process to also the process of stabilization. After a heat treating process.
Those are the castings. Those are clean. Oh, yeah, this is definitely a top-end company.
We do the deburring on the castings, and also we paint the casting to make sure to prevent it from rust. Then what we do is we set it outside for the aging process. Natural aging process, it's a process depending on the function of the castings. It goes from 30 days to 90 days. And that's where you fully release the memory of the castings to make the castings more stable. The main point is why we build everything here is to...
Okay, so I'm guessing that whatever alloy they're using, as much as we like to think is like metal, hard, solid, done, some alloys do interesting things over time. So I'm guessing with whatever the one they're using is, it will slowly recrystallize at, call it close enough to room temperature. So yeah, the crystals reform and settle into a stronger, more robust, more stable form. There are certain kinds of aluminum that will do the same thing. I think most of the aircraft grades are like that, where you can get them to harden if you hold them at a certain temperature for a certain amount of time.
Quality of the machine. We control all the quality of the machine. That differentiates from everybody else. Where a lot of companies, they're more assembly, they're not manufacturing them. So we're complete manufacturing from raw material down to the finished product. We control the process. That's why we want to have a stable, reliable, and high quality machine for the customer. Well, one of the 2 Taiwan have own foundry. So it's very important for us because that's the foundation of the machine. That's where the stability of the machine comes from. So we've had this foundry for 40 years, and over the process, we learned a lot of experience in how to build better casting for customers and how to build a more stable machine. And that's why a lot of the machines that are out there, they're running for 20 years, 30 years, and then customers continue to run the machine with the same accuracy.
Yeah, we were at Super Alloys, and they just had all these machines 20 years old.
Oh, that's a spectacular looking place. But if they're lasting 20 years old, or 20 plus years, that's excellent casting. Two, well, I wonder how much they have to refurbish every so often, and how easy it is to upgrade their motion control systems, their computers and stuff.
So just running non-stop.
Yep, non-stop. So this is for our TV series machines. Actually, that's a patented design where we have a x-axis at the base and y-axis on the saddle, so it's fully supported. So this is our special design machine especially for dyno, because it's excellent profile accuracy, because it's fully supported. So here, this is where we have the test bars, and make sure that we have a test pole. Pull tester here. This is where we break the casting. If it's up to
That's a skookum one.
all the sands that we use for the molding, basically we recycle sands. After we reuse them, we have to make sure that the sand is up to the standard for the next production cycle. Okay. So this is where we test all the sand, the laboratory that we have, to make sure that it's up to par. Basically, we use the sand to mold the shape of the casting. It's just like a mold and die. Basically, we use the sand as the mold and die to make the shape of the castings and ripping the castings. Yeah, so we're here at assembly plant number 3. This is where we build all our large machines. And to build our large machines, you need a very strong foundation. So this is what we have here. This is a very special foundation in this plant. There's 5 layers to the foundation, so it's capable of holding large machines.
Okay, that's the floor, I think. Pretty sure that's what they're getting at. That's the floor, their production floor.
You need a good foundation to build an accurate machine.
Yeah.
How the casting is being built at YCM, building everything from the bottom, hand scraping all of it, like crazy. Now, beyond the base and foundation of the machine, what else is so important that most people purchase? The spindles. But guess what? At YCM, they build their own spindles. Look at this spindle right here. Look at my hand. I have a big hand, but look at this hand compared to this spindle right here, connected to the foundation and the casting. Like, this bad boy is a monster right there. And that's why I'm excited to show you guys the spindle making process at YCM. Let's go.
We're here at the YCM spindle rooms. Here's where we install all our spindles. We range our spindle RPM from 12,000 RPMs all the way up to 20,000 RPMs. We build about 200 spindles a month here. Spindle with PC46 turning, so you can see the large diameter, so you can handle heavy cuts on the turning center. So right here we have our motorized spindles. So the more
this thing, that machine must take just monstrous cuts, or be capable of taking monstrous cuts, like 1.5 to 2 inch diameter end mill, maybe going 1 inch to 2 inch deep into material. I'd have to see the test, but I would not doubt that would be something that this could do with very little issue.
Well, motorized spindles goes from 20,000 RPM, 22,000. We go all the way up to 40,000 RPM, depends on favorite size. So we also install the motorized spindles, the built-in spindles here. And here we have a test bench for clamping and clamping. So every spindle we go through a testing to make sure that the clamp on clamp is stable, reliable. So with each spindle we go through hundreds of repetitions of testing on a clamp on clamp. So this is our temperature control room. This is where we do all the precision machining. You can see we have 2 Yasnas with color changing.
Temperature control is supremely important for a high precision manufacturing process like this, because even 1 degree of temperature change can shift. Like, it's a very small number, but very small numbers add up and add up and add up until they're not very small anymore, and they're actually a significant issue. So you want your environment to be at a fixed level, so that, and they're doing this dry too by the looks of things. So they're not going to be getting any of the heat out of the tool and out of the workpiece via coolant. It's all going to be air cooled, so you got to keep your air in the room stable. Like, if it gets too cold, the steel shrinks. If it gets too hot, it expands. If it expands, you can cut more than you intend to, and then when it cools back down, your part is undersized. Or if it's too cold, you cut too deep, and when the temperature stabilizes, it's oversized, or it's, oversized. So you want that nice Goldilocks zone of plus or minus 0.0005 or whatever.
Also grinding as well. So this is where all the high precision machining is done. The temperature is controlled at a constant temperature, and also humidity to make sure that the part that we're machining, we get the best accuracy out of it.
So Rick, you said that you guys use 70% of your own machines to make your own products. And how many of the parts inside the...
Oh, that's another cool thing. They've built the machines to build their machines, and they're using their machines they built, etc. So you know their stuff works. Like Prusa is like that too. They make their printers and they print parts using their printers. I love to see it.
The machine are actually made here.
I would say the most critical part of the machine, or the parts are done here. We do farm out some, about 40% of our parts, but the majority, most critical parts are done in-house.
Right.
So this is our control center of our machine shop. We developed this smart manufacturing platform. We started a company called .0, where they focus on smart manufacturing platform for all the industrial manufacturing companies. So here it gives you more visibility and also transparency of the factory to look at how your utilization of your equipment are, and also look at the waste, where your waste are, and how do you optimize your process, and also better productivity as well. Our factory supervisor, all he has to do is just look at this so he knows what's going on in the shop. He spun up a company again on like .0, specialized in helping customers, factories, improve the visibility of the factory and help them improve their profits.
So basically, you're turning them on to your secrets.
Yeah.
So good.
It's our JD422, so it's got 4.
I mean, why not? If you can charge for a service, charge for a service. And if it becomes a package deal where they buy your machine tool, and then you say, hey, we've got this other thing that's going to make you more profitable, sell that too.
Meter on the X and also 2.2 meters on the Y. So it's very good for aerospace applications. So you can see that it's double column structure. You have multiple linear guideways for heavier, stiffer cutting.
Very cool. What is the largest size you guys make?
The largest size here, we fill up to 6 meters, but also we have our sister company, Tree Mill. It can go up to 13 meters and also 3 meters on the Y. All right, what you see here,
That's
of course, is the
parts.
bare skeleton or bare base for the British Finish double column machine here. So you can see here, it's very well supported. We use a large linear guide, the ball screw bearing itself. So this is where we control the thermal growth of the machine, especially on the column itself. And that's important when you're doing rough machining and heavy machining. So this is the very important for the rigidity stiffness of the machine here. So when you're assembling machines, the accuracy comes from scraping. So we have a scraping standard process, basically.
So scraping is exactly what it sounds like. You get you use hand tools to level out flat surfaces. So what they'll do is they'll machine a surface, and then the scraper will go over and put down like an ink or a paint. I think it's called Prussian blue. You lay it down, you wipe it off, and where you have spots where it's still, so like the paint will sink into low spots. So that means you have to go over it and scrape it down till you get those low spots out. It's very time consuming, takes a lot of skill too, but the end result is a very accurate machine.
We make it into a science where each square inch, how many points do we have from scraping, and also the depth because of the lubrication and also the surface contact. This is basically, we made this into a standard science process to make sure that each machine is the same. So here we have our T11 and T13.
That's impressive, and a dedication to the art, turning it into a science.
This is a special patented design from YCM. What's different about it is that, as you can see, normally your x-axis is your saddle and your y is your base. We reversed it where you have the x-axis as your base and y-axis as your saddle. You can see that no matter where the table is, it's fully supported. So it doesn't have the overhang that you have on the other machines. So it gives you excellent profile accuracies. And on the saddle itself, you can see we have 4 guideways to support it to give it more stiffness, more rigidity. So this is the machine that's perfect for if you're doing some titanium, you do some Inconel, you're doing heavy cuts, but also you want some accuracy. This is the machine you wanted. The machine is T11 or T13. It depends on the size of the x-axis. Yeah, we can do different tapers with this machine depending on the type of application you're using. If you're doing aluminum, you probably want a PBT 40 or HSK 63, but also it comes in.
Okay, so the tapers that they're talking about is for the tool holders. Most of them they're a cone shape, and those numbers that he just rattled off are how they were, what the shape of the cone is.
50 taper as well, or CT 50, CT 50, or HSK 100 for if you want to do heavier cuts.
Awesome. I mean, it's absolute monstrous up there, huh?
Yeah, definitely, because we have to extend the y-axis, so you have to extend the throw. You have to make sure that the y-axis does not move. So the structure is basically very critical to support the y-axis. So here is where we small the showroom. So you can see our newest development machines here, the new 800s, some automation with 5-axis here. So right now is our open house. We're going through introducing all our new technology to our customers and dealers. So this is our new horizontal 5-axis, 600 millimeter pallet. You can see here, it's very versatile on the angles. The machining capacity is very large, so you have a very high capability for 5-axis.
We got the RX65 casting right here. And one of the cool things, like even down to the screws, when you look at the screws right here and you see the paint on it, every single screw, every single bolt, when it has the mark, the red mark, that means that they've inspected it and torqued it absolutely perfect. So if it doesn't have the mark, then it would be loose and not torqued yet. So they'll always come back, they'll torque it perfect, and they'll mark it so you know that is perfect. So super cool. This is Wing, my wingman right here. The man behind the camera making everything happen.
Thank you. Boom. So this is our standard 3-axis, and we try to make the standard and separate the target time on each assembly. So ideal target time like 7 hours. So each station by station. And of course, for the accuracy, what we made is separate as the conveyor system. The conveyor system only for sheet metal.
So another part of remember the .0, the software they have for the shop management? Let me see, that is a 360 camera, but it's not just a camera that's keeping track of everybody. It actually, like, they know movement. So the machine's finished, they'll do like a signal, like put both hands above their head and then touch. And then when that happens, the camera automatically knows that movement. It actually notifies the .0, the planning board, that machine finished.
Okay, that's kind of cool, a little concerning, but also kind of cool.
Movements can signal certain things that happen, and it registers it, puts it into the system, and logs it as, hey, this is complete. It'll notice if a worker falls, like it recognizes danger, so it automatically...
Okay, that's definitely handy, especially if people are getting busy, or lone guy walking through the shop and slips on a banana peel. There's gonna be information getting out that this guy's down and hurt, send help.
It sets off an alarm to go help somebody, so it keeps the entire place management knowing if there's like a problem, or follows the efficiency of the process, and as sections are completed in the process, it alerts the system to update it, so you don't have to have data input. Crazy, right? That's super good. Another thing about this video that I'm super excited about is you guys actually got to meet and see Rick Chen. This is one of the most humble, smart individuals I know in manufacturing, and he runs YCM with his brothers. So it's Rick, Patrick, and Roger Chen, and the rest of their family and their team. The entire team is just phenomenal. And I want to say a special thank you to everyone for the hospitality that you've given to my wife Gina and myself. We've had such an incredible time in Taiwan, visiting the entire island, talking to manufacturers, talking to students, going to TMTS, and one of the craziest highlights of my life, meeting the president of Taiwan. No matter where you are in the world, in manufacturing and in life, we are all one family. and manufacturing is done the same everywhere. G-code is the same in America, in Taiwan, in Germany, in Switzerland. It is absolutely the same. The process of making a part is the same, and our blood is the same. So to all you manufacturers out there, thank you so much for watching our videos. Thank you so much for being in manufacturing. I love you guys. Boom.
Okay. Good message from Titan there at the end. And well, let's keep this train moving. We'll go from heavy metal to something a little lighter. Airstream process 50 times faster than 3D printing from Europe's Foundry and Fibionic. This has something to do with some kind of textile, so it was interesting to see what they had to say.
We create and produce lightweight products inspired by nature. Every time you need to move a part, lightweighting plays a very powerful role. Automotive, aerospace, in the UAV sector, in the robotics sector. The main issue at the moment is that traditional manufacturing processes are either too slow, too cost intensive, are too wasteful, and this is exactly what we are trying to solve.
We have developed a fully automated production process to produce bionically optimized reinforcement structures.
So from fiber placement, securing fiber position, to consolidation.
Oh, they got something secret back in there. Of course, that's probably patented and they're not wanting to share just yet.
It's all integrated in one machine.
Saving as much resources as possible and then providing these advantages to the mass markets.
Almost any hardware product would benefit from lightweight design and the usage of lightweight materials. But current production technologies are manual labor intense and they waste a lot of this precious reinforcement material. And therefore, composites are often too expensive to use it in daily products. That's exactly where Fibionic comes into.
Oh, I don't know how much of it is the waste and how much of it is this. Just carbon fiber is complex and expensive to make, flat out. On the other hand, there's very few places that are actually making it too, so that could be something that's more readily fixed.
Place.
We always have a look at nature, how it's designing things. In nature, only the fittest survive, so only the most or the best structures survive by the end of the day. Nature had about billions of years to just like develop the ideal structures, minimum resource consumption to reach exactly the properties that are needed for a component, for a body part. Humans often tend to over-engineering. So that's why we said, let's go a step back, oriented nature, use materials only exactly where needed and nowhere else. What we have seen before is,
On the other hand, there is something to be said about over-engineering as well.
that companies are placing single fibers every roving after each other by a gantry system, which is rather slow.
So we at Fibionic, we tried to change this thought and oriented on other production technologies. We found out, let's have a tool-based production process for high volumes.
We build a tool with channels, so we input these fibers into the tool, and with an airstream, we just shoot it into these channels and then take it out and position it, making it much faster than ever before.
We are fully optimized from creel, from roving to the finished product. So we start with the creel, with our input material, which are commingled yarns, consisting of reinforcement fiber and also thermoplastic matrix material.
So you can imagine that now.
So it'll be carbon fiber mixed with, could be nylon, could be any of the 3D printing polymers. Probably not PLA, but probably something like PETG, PET, polycarbonate, PCTG. There's a broad range of what you can be using.
Like the fibers are just like fed up into our machine, and then it actually looks like this. A special gripper system takes it out of the mold and then position it and keeps like the the real fiber angles inside a plate.
By using temperature and heat, we finally consolidate our inlay and receive the final mechanical properties.
Now you have the 3D fiber skeleton. One is just put inside the injection molding machine. The machine closes, injects the plastic, and out comes the finished part. So overall, we have a cycle time of about 1 minute, like the part production and also the injection molding. And I think this is like world record for making this high-level composite material. People are asking, how do you know where to place the fibers? So within our software suite, we are having optimization algorithms, which are inspired by natural design principles, where we are aligning the fibers along the load path within the structure.
So this is exactly the digital twin of our series production product, like the one we showed you before. So this product is exactly what we can see here on the right-hand side.
Thomas is one of our co-founders, and he studied composite technology. And within his PhD thesis, he developed completely new algorithms to calculate load path optimized structures. Within this theoretically and digital world, he found out how huge the benefits and how huge the impact of this design approach can be.
I did a lot of finite element modeling and found out that there is like a nature-inspired way how to do it, like placing fibers along the load path.
And he came up with this bionic design approach, placing reinforcement fibers only where necessary.
Saving a lot of material and saving therefore also a lot of cost and also weight.
By the end of my PhD, I came out and said, yoo-hoo, I can do marvelous things in the digital world, but actually when I want to manufacture it for like hundreds of thousands of parts, there is like this big gap.
Looking into the real world, at that time there was no production technology available to really produce bionic reinforcement structures. There are even some customers waiting for it, but there's no possibility to produce this kind of structures in high volume.
We teamed up and said, there is this digital wonderful thing we can do. So let's think about how we bring it into the mass fabrication. And we sat together, just like made up our brain, our mind, and found what we're doing now. So just shooting fibers into a tool with channels.
I wonder if they're actually
hand-built. What's missing is her story. For decades,
I wonder if they're actually gonna show how this works, or if they're just gonna gab about it. Oh, look at this thing, what we can do, but we're gonna show you what it is.
taught to fear the future, not build it. That's why we are making documentaries about the engineers, scientists, and founders building the future here in Europe.
We have many things that just like help sustainability. Bionic design uses much less fibers than any other technology. During our production, we have very little waste material, which is also helpful for sustainability. And then parts are lighter, so during the use, they consume a lot less CO2, for example, as well.
Yeah, of course, it always comes to CO2 these days. How about looking at fuel efficiency or energy efficiency? Extending the lifetime and range of your product instead of focusing on something that's so insubstantial yet overhyped.
And our parts are also recyclable. So at the end of product's life, it is possible to just use these structures again, to shred them down, to recycle them mechanically, and just produce this kind of pellets or granulates, which can be used in injection molding, and they can even go to the same product again. We are using carbon fibers, and they are like commingled, or they're hybrid fibers with thermoplastic fibers. But we are also going towards natural fibers, like, for example, hemp fibers. We can go toward glass fibers or aramid fibers or any kind of...
And aramid is Kevlar or Spectra, that kind of class of fiber.
Reinforcement fibers you actually want to use. The materials we are using are actually co-developed with our suppliers, so there was a lot of work also just like finding the right material setup. We are using about 55 volume% of carbon fibers, which is quite all right. We can go up to 60%. but just finding out the right recipes for our specific process was challenging. We had to develop much more than we expected because like everything you get on the market was just like too expensive for a startup. So we really had to go to the scratch.
Yeah, that's unfortunately the way things go. Nobody wants to give money to a startup unless you got something spectacular. And even then, it's iffy.
Think all the process steps and just do them by ourselves. So also like, as I explained, like we also patented the consolidation process. That's not because we wanted to, that's because we had to, and to find a more or less not that costly solution. One of the big challenges with our technology is that you don't have to do like a single process step. What you need to do is building a whole ecosystem. So you have to provide software to tell people how they design their product. You need to go for prototyping with country systems. You need to think about the forming, and then you also need to think about the series production. So we are building a full ecosystem consisting of software, hardware, and also material. And I think this is the really challenging point. So it's so much work to do. We did this with about 5 people, and I think this is really underestimated. So
It's actually probably the best way to do things. Have as few people working on it as possible. Because if you get too many people working on it, one, you're going to burn through your budget in a hurry because payroll is a bitch. And, well, people get kind of upset when they don't get a paycheck. And two, you don't get overlapping and over-conflicting opinions on stuff. Keep your team as small as necessary or as big as necessary. Don't go adding more people and thinking, oh, I've got a great company because I have 100 engineers working with me. No, 5 is a good start. Preferably 5, and each one has their own specialty.
you model it in our software, and then you get like the manufacturing recipes for our gantry system or for our series production.
I'm thinking it's supposed to be gantry system that he's talking about. Autodub is auto-corrupt.
Machinery out of this software. So it's an important point to scale and to bring the technology to the people and not design every part just by ourselves, which is important just to produce these parts in like the big numbers.
We are growing so fast, we are trying to expand, and we actually need to expand our space. That's why we now have our second office here, where some of our employees are located.
Everything worked out pretty well, and then starting this fiber inject machine, making thousands of parts. And I think this is now also a point where you see this is scalable, this is industrializable, and this is actually the point where you see that it can work. As we see here, we can even play around with our technology.
Those are some pretty complex shapes that they're running.
We just like have new employees, and they tried like some different kind of fiber trajectories just on their own, and that's pretty easy with our prototyping hardware systems. Innovation only comes from innovative companies, and I think there is nothing more innovative than a startup. Just like bringing some very motivated people together and then living their idea and living their dream. I think nothing just like has more power than that. I think in Europe it would be good to have more startups to just like drive innovation, to go for new challenges, and just like also to empower young people. Europe actually has great talent, great research, especially basic research, but I think it mainly lacks from the way out of university to using it in business, for example. And I think this is one of the biggest mistakes Europeans are doing. I think they stop when it really gets interesting.
Sometimes people come to us and ask us, you are...
I wonder how much of that is culture and how much of that is government red tape getting in the way. Because the EU is particularly horrible for absolutely stupid laws.
Are another 3D printing company, and that's actually totally wrong. We are creating a totally new approach of how composites are produced, being much faster than any kind of 3D printing technology, as we applying an airstream process that allows us to position one fiber layer in just milliseconds.
Our goal is that everyone, by the end of the day, thinks about our technology and uses it in their parts, because we want to make parts lighter, we want to use less material in these parts, and therefore change also like the ecological footprint of these parts.
Our mission is to make lightweighting affordable and sustainable, establish a new production standard for the production of lightweight composites.
Well, that was interesting concept, a little bit disappointing we don't actually get to see the process. Maybe something will come out later on. Now, what's next? Anastasia in tech. The new superconductor? New chip breakthrough from somebody. Intel potentially. Well, let's see how our computers are going to change in the next 2 to 5 years.
For more than 50 years, the semiconductor industry had a simple answer to almost every problem: make transistors smaller. And it worked incredibly well. But after attending several major technology conferences this year, one thing became very clear: that roadmap is over. And what's replacing it is far more interesting: a completely new way of building computers. One that could eventually shrink an AI data center spanning more than 100 football fields into something closer to the size of a refrigerator. Now,
Whoa.
that sounds completely insane. But after spending more than a decade building advanced chips, this is one of the most interesting solutions I've seen in years. Because it doesn't try to build a better transistor. It tries to change the physics of computing itself. And if you're subscribed to the channel, you're awesome and you're gonna enjoy this one. Right now, the largest AI companies are building data centers so massive that they require dedicated nuclear power plants just to run them. Many people think that AI energy crisis is caused by too much computing. But modern chips are actually extraordinarily good at it. The real problem is moving information. And right now, as AI shifts from chatbots to agentic AI, which are autonomous systems, this problem gets dramatically worse. Because instead of generating a single answer, AI agents increasingly search, reason, call tools, access memory, verify results, and coordinate with other models. In other words, every step requires data to move. And eventually, moving information.
So it stacks. You're not getting 2 plus 2 equals 4. You're getting 2 plus 2, and I need to check with this thing. I got to cross-reference this thing, and I got to look at this math book and that math book and that math book and this professor and that guy over there, and then you get 4. So, and that all takes time. It takes a very short amount of time to our perceptions, but it all takes time and it all takes processing.
Information starts costing more than computing itself because physics gets in the way. Inside a processor, billions of electrical signals race through tiny metal wires. And as electrons move, they interact with atoms in the material. We call this resistance. You can think of it as friction for electricity. And as any other friction, this wastes a lot of energy. That energy doesn't disappear, it turns into heat. Tiny amounts at first, but when trillions upon trillions of signals are moving every second across an AI data center, those energy losses become enormous. And that means that a surprisingly large amount of modern computing is actually a battle against heat. For 50 years, we made...
And that battle against heat is one of the biggest reasons why Musk is looking to put so much stuff in space. Because you got nothing but a giant heat sink out there, as long as you can keep it in the shade.
Computers faster by shrinking transistors. But the next 50 may be about something else entirely, like making information travel less. Or, even better, removing the costs of moving information altogether. And this idea leads directly to superconductors. Now, when you hear the word superconductors, you probably imagine some incredibly complicated physics experiment, something like LK99 and floating magnets, or a setup resembling a quantum computer, which is so sensitive that any tiny disturbance from environment just ruins the computation. But the basic idea behind superconducting computing is very intuitive. Remember the problem of moving data we just discussed. It turns out certain materials, when cooled below certain critical temperature, enter a completely different state of matter, a state called superconductivity. And in this state, electricity can flow with virtually zero resistance, which is remarkable because you've just removed the biggest energy cost in modern computing. But that's not the clever part. The clever part is that they got rid of the transistor. Instead, superconducting computers use a different device, something called a Josephson junction.
Okay. It does make sense, because the way semiconductors work, or processors work, is you run electricity through, basically it's junctions of different materials that react differently. They either they become conductive once you have a certain amount of energy flowing through them, or they're resisting, or one of a myriad of other things. It's very complicated. You're making rocks do math. And that's a level of magic I'm vaguely aware of how it works.
And despite the intimidating name, the idea itself is actually quite elegant. It's basically a sandwich where two superconductors separated by a thin insulating layer. And when it switches, the junction emits an incredibly small and precise pulse of magnetic flux. Researchers call it a single flux quantum. And you don't need to remember that name. What is important is that this tiny pulse becomes the basic unit of information inside the computer. In a conventional processor, information is represented by electrical signals switching on and off. But every time they travel through the chip, some of their energy is lost as heat. And as signal moves through the wires, we also lose some of the information. That is one of the fundamental reasons why modern data centers consume so much power, while superconducting circuits work very differently. Instead of moving relatively large electrical signals around the chip, they use tiny quantized pulses. And because the surrounding wires are superconducting, almost no energy is lost along the way, which is a pretty remarkable idea. And the numbers start to sound ridiculous. A single switching consumes only around 1 millivolt, compared to roughly 500 millivolts in a modern transistor. And that's about 500 times less voltage and potentially tens of thousands of times less switching energy. But the energy is not the single advantage. Another one is that these pulses are extremely short, roughly 1 picosecond in duration, 1,000 times shorter than a nanosecond, which means the logic can operate at frequencies conventional processors will.
Yeah, because a picosecond? I'm not even sure. Like terahertz frequency potential? And most of what's in our computers right now is within 2 to 4 gigahertz, or 2 to 4 billion. Pico, I can't remember. Okay, yeah, pico is 1,000 times smaller than a nano. So yeah, it would be a terahertz. And very interesting things happen when you start working at terahertz frequencies.
Never reach. Modern CPUs typically run around 3 to 5 gigahertz, while these superconducting processors have already demonstrated operation beyond 20 gigahertz. And some circuits have exceeded 100 gigahertz because many of the limits that slow down conventional chips simply start disappearing. Now, at this point, you might be thinking, cryogenic temperatures, superconducting circuits, all of that sounds very familiar, like quantum computing. But here is the important distinction. The devices themselves rely on quantum mechanical effects, but this is not a quantum processor because it performs classical binary computation. There is no quantum superposition involved, no entanglement, no exotic quantum algorithms. And honestly, that can be one of its biggest strengths, because the problem of quantum computers isn't building the hardware, it's building everything required on top of it. The whole stack, including software and the algorithms. Quantum computers aren't faster versions of modern computers, they're an entirely different computing paradigm. While the superconducting circuits still perform classical computation, just running on a fundamentally different hardware.
So basically you could, if you were running one of these superconducting circuits, you could run everything that already runs on your laptop or desktop, your cell phone, because it's using binary, which is just switching on and off 1, 0. Whereas quantum, I'm not entirely sure what the actual technology of it is at the moment, but it'll be like, you'll have, so instead of zeros and ones, you'll have like 0, 1, 2, or 0, 1, 2, 3. And so it's those different states that that add to its computational complexity. All right. But yeah, binary. So you could slap your Windows onto a superconducting chip, or to run it off a superconducting chip, and it would run just fine. So it would run way nicer because, well, Windows is kind of a resource hog. And having 4 times more processing speed might actually make it worth keeping around.
And this means the industry doesn't need to rewrite the decades of software just to use them. And that makes the path from lab to real product much more realistic. But if superconducting...
And the other thing is, the production of transistors like that, if you've got 2 superconducting layers, all you need for an insulating layer is pretty much any other metal, because it's like you could go superconductor with copper sandwiched in between. You're still going to keep very high conductivity, but the copper is high or has a high enough resistance versus the superconductor that it would act as an insulator.
Computing is so compelling, why it isn't everywhere. And this is where a story gets difficult. And the answer has very little to do with physics. For more than a century, researchers have known superconductivity was real. The challenge was turning it into something manufacturable. The devices were difficult to build and very difficult to scale and nearly impossible to justify economically. So despite of decades of promising research, superconducting computing remained trapped inside research labs. Until IMEC decided to take another look. IMEC is a research lab based in Belgium. And if TSMC and Intel are where future chips are manufactured, IMEC is often where future chips are invented. It's one of the few places in the world where the semiconductor industry comes together and experiments with technologies that may not reach commercial products for another decade or so. And recently, IMEC decided to revisit this, one of the oldest computing dreams, superconductivity. Not because the physics suddenly changed, because for the first time, superconducting computing started to look more commercially realistic. The question is if the remaining challenges are worth it. And we will deep dive into that in a moment. But before that, as someone who travels a lot...
The biggest problem with superconducting anything right now is the superconductor. There's very few materials right now that can be mass-produced and have an accessible cooling regime, aka you can keep it superconducting at liquid nitrogen temperatures instead of almost absolute zero, that is liquid helium. Liquid helium that's a critter that's a whole bunch of strange.
And runs multiple teams across airports, calls, and meetings. I really appreciate good communication quality. I've been testing the new Soundcore Liberty 5 Pro series, and I am impressed. These earbuds are built around Anker's custom AI audio processor using a compute-in-memory architecture that fuses processing and memory together to highly improve the performance. With 10 sensors constantly monitoring your environment, the earbuds can isolate your voice in real time, even in chaotic surroundings. And for how I work, taking calls between flights or jumping into meetings from wherever I can be, that reliability matters a lot. They even set a Guinness World Record for call clarity in noisy environments. Then there is an active noise cancellation. It continuously analyzes the environment around you and generates the opposing signal needed to cancel the noise dynamically. The Pro
That's pretty cool. Definitely an interesting set of earbuds. Wonder what they cost.
Max version adds a touchscreen case and AI note-taking features, and you can control the playback or switch ANC modes directly from the case. The feature I ended up using the most is AI note-taker. I just double-tap the case, it starts recording, transcribes the conversation, generates a summary, and even pulls out action items automatically. And that genuinely simplifies my day, because instead of trying to remember what was agreed to in the meeting, all the notes are already organized for me. If your calendar looks anything like mine and you value communication quality, make sure to check them out in the description box below. Now, IMEC showed that many of the problems that held the technology back may actually be solvable. Their approach is built around the material called niobium titanium nitride. And unlike many other superconducting technologies, it can be integrated into existing semiconductor manufacturing recipe.
I've never heard of niobium titanium. What was that?
Called niobium titanium nitride.
Niobium titanium nitride. Interesting. Gonna have to look that one up because I think the one most common right now is RCBO. It's rubidium, cobalt, barium, copper oxide. It's a ceramic. Yeah, I'm definitely gonna have to look this up.
Unlike many other superconducting technologies, it can be integrated into existing semiconductor manufacturing recipe. These devices can be fabricated on standard 300mm wafers. That may sound like a small detail, but it isn't, because it means this technology finally has a plausible path to mass production. But the really important innovation is hidden inside the sandwich, inside the Josephson junction itself, in the tiny layer separating the two superconductors. For decades, that layer was one of the biggest obstacles to scaling this technology. IMEC replaced the traditional aluminum oxide barrier with amorphous silicon. And that change may sound minor, but it makes the device dramatically easier to manufacture at the densities required for real computing systems. Except for one problem, which is impossible to ignore. This is actually the reason why you don't have one of the superconducting circuits in your laptop today. Superconductivity only works when things get extremely cold. We are talking about roughly 4 Kelvin. That's minus 269 degrees Celsius, just a few degrees above absolute zero. And that means you cannot simply put one of these chips into a normal server rack. Instead, the processor sits inside the specialized cryostats. You can think of a cryostat as an ultra-advanced scientific refrigerator. Its job is to keep the entire computing system just a few degrees above the coldest temperature physically possible. And that's usually the first criticism. Does any of that make any sense? After all, cooling something to 4 Kelvin sounds incredibly expensive. Wouldn't the cooling system consume more energy than you save? Surprisingly, based on the IMEC research, the answer is no. For small systems like your laptop, this doesn't make any sense. But the larger the system becomes, the more advantages you get. In fact, according to IMEC's analysis, there is an inflection point. Below a certain scale, cooling a superconducting computer costs more energy than it saves, so it makes no sense. But once you reach the scale of today's AI infrastructure, the math flips. The energy savings become way larger than the cooling penalty. But there is another advantage, which is even more important: density. And to understand why, it helps to imagine what one of these future systems may look like. At the center sits a superconducting processing unit. Think of it like the superconducting equivalent of today's GPU. But unlike a conventional chip, much of this hardware lives inside a bath of liquid helium at around 4 Kelvin. Then, through a thermal bridge, the system connects to a warmer region, running at around 77 Kelvin. Still incredibly cold, but warm enough for conventional silicon DRAM memory to operate much more efficiently. And beyond that sits the normal world. In a sense, it's a computer system built across 3 different climates. And this is where it starts to get really interesting.
So that is interesting. I think 77 Kelvin is roughly where liquid nitrogen sits. I'll have to check. But there's plenty of hardware that semiconductor hardware that would be just fine at those liquid nitrogen temperatures. Stuff like capacitors might get a little iffy if they've got electrolyte in them, but you just don't use those.
For decades, semiconductor industry increased performance by shrinking the transistor. But because of the physics wall, now it gets harder and harder. So what's happening? We are trying to build transistors and circuits and chips in the third dimension. Stacking memory on top of processors, stacking chiplets, and eventually stacking entire systems. But the problem remains. It's heat. Modern processors already struggle to cool a single layer of silicon. Stack enough layers of logic on top of each other, and the chip eventually cooks itself.
And it can cook itself in a very spectacular manner. I've seen tests where they've been running full tilt and then pull the heatsink off the processor. And yeah, the processor exploded with enough force to blow a hole through the table it was on. Not good times.
That's why today we are moving towards stacking memory on top of logic, not logic on top of logic, because this will simply burn the whole thing. And when we are able to stack memory on top of logic, we are able to shorten the distance and increase the bandwidth without killing the thermal budget. But superconducting systems completely change that equation, because they generate so little heat that logic chips can potentially be stacked directly on top of the other logic chips, layer after layer of computation packed into a dense 3-dimensional structure. That means shorter distance for data to travel and higher bandwidth. In fact, IMEC modeled such a future system which would be built from 100 superconducting circuit boards, and it would fit into the size of a shoebox and deliver over 20 exaflops of compute.
Holy crap.
That's roughly 20 times more compute than today's largest supercomputer. And it would consume only about 500 kilowatts of power.
So, the size of a shoebox and pulling the same amount of power as about 10 houses?
Not hundreds of megawatts like modern data centers. And if those projections hold, we are talking about at least 100 times improvement in energy efficiency. And the huge idea behind it is not to build a faster computer, but to build a denser computer, which can deliver drastically more compute from the same amount of power and from a way smaller footprint. Because in the AI era, power and space have become some of the most valuable resources in computing. For a laptop, cryogenic cooling makes no sense. But for an AI data center consuming gigawatts of power, the economics looks very different. And that's exactly why the AI industry is paying attention. And interestingly, this is not the only attempt to solve this problem. Recently, Huawei proposed so-called logic folding.
We found the breakthrough. We name it the logical folding.
Which
So whose patent did they rip off?
is extremely ambitious claims, and I'm working on an episode about this. If you don't want to miss it, remember to subscribe to the channel. Now, here is something interesting. We don't have a factory for superconducting logic, at least not yet. But the industry is already investing billions into something closely related: quantum computing. Right now, IBM is building a massive new manufacturing facility near New York, fully dedicated to quantum technology. At the first glance, that may sound unrelated. Quantum computers and superconducting logic are two different things, but what's interesting, underneath, they share the same engineering challenges. Both of them rely on superconducting materials, both operate at cryogenic temperatures, and both require advanced packaging and specialized manufacturing processes, as well as electronics that can function near absolute zero. In other words, while IBM is building factory for quantum circuits, they're, by the way, solving many technology challenges needed to commercialize superconducting circuits. Because for decades, superconducting electronics had a chicken and the egg problem. Nobody wanted to invest in manufacturing because there were no products. And there were no products because there was no manufacturing ecosystem. Now, quantum computing is helping break that cycle. And for the first time, there is a serious industrial effort to build computers that operate just a few degrees above absolute zero. And that's why I find this technology so fascinating. But AI is exposing a new bottleneck. Distance. Moving information has become expensive. Heat and power have become expensive. And superconducting logic attacks all three at once. Not by building a better device, but by rethinking how information moves through a computer and optimizing everything around it. Now, to be clear, I don't think superconducting logic will replace silicon. Your phone and your laptop will remain CMOS-based for a very long time. But for frontier AI data centers and
At least until somebody cooks up some room temperature superconductors. That will, once that happens, and it's relatively cheap, computing and a lot of other stuff start to look wild.
in future quantum systems, the equation starts to look very different. Because once moving information becomes dramatically cheaper, something interesting happens. Compute is no longer need to be concentrated inside ever larger facilities, but it can become denser, more efficient, and way closer to where it needs to be. Closer to factories, to the available power grids, much closer to the real world. And that may be the biggest shift of all. If you enjoyed this episode, you will definitely love this one, where I break down the most fascinating microchip factory being built right now in Texas. Or this one where I explain how particle accelerators are saving Moore's law. Love you guys, and I will see you there. Ciao.
Okay, well that was a good one. There's a wild potential in the not so distant future. Superconducting processors transmitting data through optical systems. It's exciting, but I promised an explosion. So here it is. Buster Jangle surface detonation. The only true surface burst nuclear detonation of 1951. Courtesy of the Atomic Test Channel, which has all kinds of goodies from the long bygone days of unleashing the sun upon the surface of the earth for science and intimidation. Wow. crazy how it just whites out the camera so fast. And then it resolves to the explosion. Gotta love the music they chose for this. Let's make it as ominous as possible. So I'm guessing these streamers are smoke generators or something. Maybe to see how the shockwave ran. Doesn't look like it distorted them too terribly much. Okay. Now, post the last two links. Back. And I think I'm going to take a short break, and then we'll come back and figure out what we're going to play. Hang tight, everybody. And I'm back. Welcome, Amelia. How have you been doing tonight? Just got finished watching some YouTube videos, and now I'm trying to decide if I should be playing some Destiny 2 or keep going with Pragmata. I think I'll go with Destiny 2 tonight. I broke down and bought the last of the DLCs, so can start working through that, I guess. If it decides to load. The other thing with Pragmata, I was running into some performance issues last go around, so I'm not entirely sure how things are going to run there. And Destiny was running a lot better, so we'll try that. I miss this music. Bungie always did have a way with the music. Always got good composers. I guess Marty O'Donnell now is running for Congress or something. Weird switch, but I guess you go where you need to go. Large XP boost. Midlands Cosmetics Bundle. Now available for redeem. I might have to do that later. New aspects. I did buy the content pack. Does that mean I get the... Oh, I do get the completely unlocked package. Turncoat. What's this one do? Latent power. Okay, it's a void hand cannon. Dealing damage builds latent power, precision hits and final blows build more. At full power, holding X to trigger unleash power. Empowering the weapon with increased rate of fire and hip fire accuracy, causing the shots to weaken targets. After a short time, it becomes overwhelming power, which deals damage to you over time. Reload or stow the weapon in these effects. Real double-edged sword shit going on there. Not really a fan of that sort of weapon. But it looks like it's super accurate, so... it might be fun to play with. What's this gonna look like? It's shiny. Not my cup of tea, though. Bumper boat. Oh. Okay. Go up to, Oh, it's an 8-ball. That's kind of clever. Have it show up to, Sparrow Racing in that thing. Oh, they've got horn mods now. That sounds like the Elixni were making the horn choices. Huh. Okay, enough playing with that. We got quests. Quests. Like Edge of Fate. Still gotta blow stuff up with solar abilities. Yeah, we'll go here. See what's there's to see. And then I think we'll jump into the Edge of Fate. See what all that story has in store. If it loads. It loads a bit slow. Huh? Armor. All armor pieces have mod slots which can be equipped with a variety of armor mods. Mods can be subtle or drastic effects on your combat performance, so choose carefully. Yeah. Turtle Lord 73.
Gonna need someone to shut off the power.
Oh, it's busy in here tonight. Wanted Reach of the Reef. Hey, Banshee, what we got?
Special?
Patron of Lost Causes. Missile Edge. Rats Attacks. Ooh, a Death Adder. Lucas Rose. Multi-Mot. Rose.
Don't get burned.
Eververse isn't just a title, it's a promise.
Welcome back.
Okay, pretty empty in here. Lots of people. Lots of stuff. Raveler. Oh, the spire is not there anymore. I don't think. Oh, yeah, it's still there. Never mind. Ah, no. That's kind of handy. Now how can I turn around? There we go. Need to get a thumbnail. Video? Put me in. Motion blur off, yep. Or is it in gameplay? Auto opacity. Off. There we go. Get out of the way. There, now I've got a thumbnail for my Destiny content. Back on. Don't know if I need the Tartarus gauge right away. I should jump over to Savathun, to the forge, the foundry. Enclave? The Enclave. See if I've got any more weapons unlocked for deep sight. Or is that something that they just got rid of with this last season? Or this last DLC? Well, with the new inventory stuff. Okay. Down, down, down. Deep in the ground. Okay, it looks like they haven't added anything new. Yeah, no, looks like there's nothing since, what's this one? Or that was Season of the Witch, I think. So yeah, they must have gotten rid of all the, or not picked up craftable weapons again. Instead of its focus rolls. Succession. Right, they added deepstone weapons. For some of them at least. I forget. Oh, yeah, linear. Not a good name for a fusion rifle of any stripe. If anything, it applies to the what's it called? The toaster, the Jotun. Actually, I should drag that out. That could be fun with this build. But I'm just trying to get the Dragon's Breath built up. Okay, enough dawdling. Let us go, I think, to Kepler. Continue Edge of Fate. Welcome, A9. Hope you're having a good night.
These Ionians were able to temporarily stabilize the singularity. They prevented their planet from splitting until someone could help. I'm as surprised as you they've eluded us for so long, but this place is shrouded in dark matter. It could have cloaked the presence of sentient life from the outside. Ghost, did you find the source of the distress signal?
We've made contact with Lodi, here in the settlement. He's offered to help us look into our invitation, if we help the people here. He seems trustworthy, but his presence here feels very convenient.
Yeah, by the look of him, I'd say he's as out of place as we are.
By, roughly 1,000 years, maybe? Language of the interface is indecipherable, but the altar appears to be unpowered. Cannot process a strangelet capsule integration. Ghost is tracing power transfer from the altar site. The source appears to be a dark matter conduits. The source appears to be dark matter conduits, most likely kept away from the Aeonian security zone for safety. Ghost believes it's possible to restore power. Okay, yeah, gotta do it. Okay, not a good spot. Activate matter spark. Maybe later. Interesting looking guns. They're roughly humanoid. Okay, so this is a message board. Oh, this is an active combat zone. And there, everybody here is just chilling as it pops off. Like, really? Seriously? Okay. Is this Warmind stuff? Oh, another resource. Resource tab of your map guide. Oh. Oh, interesting.
Hello? This is Lodi. Ms. Ray said you received my distress call. Ms. Ray asked that I contact the little Sputnik to work with you both on next steps.
Sputnik?
Is there something I should call you? Apart from Guardians, of course.
This is the Guardian. You can call them Guardian, thank you. I am called Ghost.
Pleasure to be working with you, Mr. Ghost. The Ionians are in less dire straits now, but if anything triggers the singularity, we risk losing the planetoid. Between a black hole on one side and the Archon on the other, the locals had no choice but to seal their settlement. They've been trying to track down that capsule you picked up for ages. Head to the big mechanism at the center of the village. The Ionians call it the Altar of Relativity.
This the thing he's talking about? Oh, there's more over here. Okay. Weird. Okay, do we gotta go back up here? What are you? Kielsk. Former from the House of Exile. Described by Alexei Rennet. Wearing exile colors. Eyes wary, distrustful. Bunch of organic gunk on him. Looks an awful lot like Egregore. A different coloration. Cannot discern the intent of behind his insect-like chittering and makes no attempt to clarify for your benefit. Well, this isn't the right spot. Huh? Oh, there's a goodie there. Guys, and just jet around as a ladder spark for a little bit. Yep. Okay. How do you jump as a matter spark again? Okay. Oops, oops, him. Nope. Okay. Matter spark. Jump A, dash forward, or right trigger, or left trigger. There we go. This hole. Oh. Really? Okay, don't go high speed into the fan blades. Yeah. Now, why would I want to watch some dude fried out on fence shooting up his own house? Okay, there we go. Okay, I don't think this is where I need to be. Okay. Okay. Each stack of war mine charge increases my weapon and grenade stats. And while I have, if I've got 4, hitting powerful combatants, destroying a construct, or destroying a tangle, or solar detonation. Ooh. What's a construct? Oh, barricades, turrets, stasis crystals, and other objects created in the field. So Warmine cells back. Basically. Just not in the best way. Welcome to the stream, BB6. Why is my sensitivity so low? That's a bit better. As you tread through Caldera, the Aeonian catches your attention. You hold a vial of radiolaria and gesture towards the gorge. The Ionian makes a hand sign and speaks a chime-like word that you recognize as the holy the holy anomaly. You get the sense that it is under threat. Okay, I've gone around in a circle. Okay, where is this thing? Oh.
Guardian, the trail we followed here to this planetoid is the strongest through that mechanism.
The singularity must be beyond there. Contained, thanks to the Ionians. If Drifter's right, the source of our invitation and the source of the singularity are one and the same. I think the 9 are here. Keep this to yourselves for the moment. Our top priority is stabilizing this planetoid. Unless the 9 plan to interfere, they're not a concern.
Lodi, we're at the altar.
Mr. Ghost, this is Lodi. Excellent. Go ahead and drink the contents.
Drink?
No, that can't be right. You do not want to do that. Say again, do not drink the dark matter in that container. Pour the contents into the mechanism. Hold on, I was provided a diagram. I am so sorry. Ionian verbs change based on the size and shape of the container. I'm still getting a hang of the beverage cutoff. Seems to be somewhere around 2 liters. Anyways, the canister contents need to get poured into the mechanism, and all you need to do is drop it in.
Okay. Where am I supposed to be going? Ah, okay. Form right of maintenance. Okay. Our gravity captured your attention. Remain attentive. Okay. Now what? Filter relativity appears to be a relic of bygone era, a jump drive converted from pre-golden age technology. Been damaged and repaired with components that are obviously straining to contain the forces surging inside. Ghost remarks, singularity stabilizers likely aren't an on-off. Yeah. Singularity stabilizers likely aren't an off-the-shelf item. The Ionians have been extremely clever and resourceful in assembling this complex device, despite their relative lack of resources. Still, the altar is definitely unstable. Strangelet capsules appear to be the only method of effectively stabilizing the altar, and by extension, the singularity. Dean Rebecca met.
Guardian, Mr. Ghost, allow me to introduce you to Dean Rebecca, leader of the Ionians.
Dean Rebecca. I've never heard the name Dean. It's beautiful.
Well, the Ionians use a sort of academic hierarchy from what I can tell. And wait, you've never heard the title Dean before?
No. Is it an Ionian name?
No, they use it as a mark of high status here. Oh, and so you know, they haven't seen other humans in centuries. Be patient with them. Our presence here is tremendously significant.
Oh, so they might be lost humans. Not a totally different species. You hear the stranger speak, but can't understand. Bottom of her helmet, you see a tear fall to her tunic. You can't understand her, but know it's the universal language of prayer. She gestures to the distance towards the influx of Vex, and from her intonation you infer a Vex mine threatens her settlement. Well, we can fix those.
Translating what I can, the Dean's honored to encounter the first new humans in centuries. She says the Ionians' deity, the thing they call the holy anomaly, is on the other side of the altar, threatened by the singularity. The capsule we put into the altar stabilizes rings of the lock to keep the singularity contained. It's a collection of dark matter she called a strangelet. You'll need to get through the lock if you want to find out what's on the other side. We'll need your muscle, Guardian.
Well, we got that. couldn't pass up an opportunity like that. That's the advantage. Okay, where are some more effects? Oh, hobgoblins. Or is it just a graphics glitch? Okay, 5 more vote. No. Noticed that before.
So Lodi, tell me more about how you got here. The more we know, the better chance we can find a solution.
All I know is I woke up here 4 weeks ago in a singed suit. I don't remember how I got here. I know I'm from Earth, I remember my family, but not much else.
That sounds like how a light bearer would wake up. But you don't have a ghost.
No, I'm alive. I mean, you probably know more about this place than I do. But I do remember hearing Guardians have a complicated relationship with memory. Is there any truth to that?
That's a fairly common question. Guardians forget who we were before our first resurrection. We forget in exchange for the light.
Shame. Feels cool.
It's a little bit cruel. Got hands for everybody. Dean eyes you curious with curiosity and recognition. You return with newfound understanding. Our languages converge. I am filled with delight and questions. There's so much I wish to know about the world you left behind. But first, the world we inhabit now is troubled, and our altar's connection to the holy anomaly is disrupted. It is a signal that calls for your answer.
Drifter? You brought them my message, capsized. Find my frequency. I'm not Neon.
No way. Orin. Neon. Orin, what happened to you? I thought you were locked in as the Nine's errand runner. You were gone.
Yes, but my memory is a mess. It's all vetiver. Damn it. Rig transponder. You can pinpoint my location.
Okay. This way. Alright, I got this. Boing.
The hell, Orin? Why do you sound like you ate a dream journal?
Petrichor. Damn it. I am not adjusting to linear time well. I am no longer emissary. I quit.
You quit?
Okay, that is out of bounds. Huh? Glowy warp thingy? Huh. Thought it could explode with that. What's this? I'll find out at some point. Oh. Yeah, are these deliberately invisible, or is this a texture issue? Another switch. That does nothing at this point.
Thought you'd ascended or something. Become a higher being. I didn't know you could quit being emissary.
Me either. But with the right motivation, anything is Starlight. You'd be proud. I'm malted.
Oh, I have to know what you mean by malted.
Exactly what it sounds like. I wanted my body back. I wanted my will back.
And so, by God, she took it back. Named one.
We gotta find her. She only just found shoes, for Pete's sake. Got your location, Orin. Never thought I'd hear from you again.
Scrambled eggs. I meant to deliver a message, but can't remember what it is. I know the 9 will need a replacement emissary. They will not find one nearby on the X-axis. They will need to search a millennia up and down the Y.
Round and round in circles.
My message found you. I'm Orin, once a Guardian, like you. When I last reached out to the Vanguard, I warned you of the 9's fallibility. The results of that fallibility are in play now, I think. You will fix it. But how isn't clear. Everything I knew is scattered. My will, cleaved from service and rough-hewn clay. It wasn't bloodless, but I know I chose this for a reason. I did. In my memory, when I touch my hand to the moment, I am overcome with dissonance and another shape buried in noise assuming my place. I must speak sharpness to the drifter, a tint on knowledge held but still unknown. I'll need your help hunting down the fate that brought us here.
So, Orin, you quit and now you're just here?
Mitosis. Annoying you had to see me like this now. Scrambled eggs in someone else's shoes. How have you been?
Oh, busy. Feet planted on the ground more often than not. Seeing someone new these days.
Oh. Oh, good. Good for you. Can't say the same. I've been too busy corralling my electrons. Who are you seeing?
It's, Eris Morn.
Oh! You have a type, Drifter. I'm happy for you both. Really.
There's goth chicks, and then there's Eris Morn. The gothiest goth chick. Okay, that must be up inside. There's another one. Ah, it is a... Oh, what? Thought I had the thing. Edge of Fate. As you access the interface, it melds with Rosetta, speaking words from an Ionian into your inner voice. Anomaly blessed. I am Rojin, Altars technician, and one honored to deliver what help we can. We offer in awe our findings to aid you. Should you see fit, our impressive drone will receive actionable data to locate the strangelet capsules. Your impressive drone will receive actionable data to locate strangelet capsules, then use the altar's relativistic connection with them as a cipher to pass into the coordinate regions of Kepler. With our current integration and research, you will gain access to the Central Academy and the Exiles Accord. There is a brief pause as Ghost accepts the data transmission. Most gracious, anomaly blessed, transfer commencing. We shall continue our research into the other stolen strangelets. With further integrations, the remaining capsules will increase synchronicity with the altar and allow us to impose a shifted perspective that ignores accordance by our observations of the strangelet beyond them. It is a delicate alignment, but our efforts can only improve through iteration. Oh, and okay. Locate the emeritus in the Ionian campus to obtain more information about the strangelet capsules there. The emeritus is a retired scientist among the Ionians. Theoretically, practically, he is still hard at work, heading up strangelet research on the Ionian campus. Have the most up-to-date information. Go to the Ionian campus to meet with him no matter what you can. I mean, being able to read, probably not a bad thing. Last Thursday. Dude. What's this do? Transcendent moment. Final blows grant bonus stats based on the weapon damage type alignment. Light elements grant stability and handling. Dark elements grant range and aim assist. Exhaustive research. Ooh. Aiming down sights at a short amount of time blows a homing micromissile. And dragonfly. Ooh, this is a fun looking one. I need kinetic. I'll switch back to Palmyra and what's something with a little bit more reach? There we go. Deadman's tail. Although I did have another type. Scout rifle. Damage type kinetic. Ah, crap. Wasn't servant leader. Ah, last right. And I will change. solar assault rifle. Yeah, why not? Plus, really chrysalis. Haven't taken that out in a while. This has dragonfly on it, I think, though, so. This is a classic ringing nail. Dragonfly, high caliber or ricochet rounds, shadow focus lens, tap the trigger. Oh, right. Alright, forgot about this one. This one has a lot of bullets. Okay, gotta go that way. Why does it... Is that what the autoloader does? Harmonic resistance. Oh, that was on the legs. Harmonic holster. Oh, wait, that's Equips. Hitting combatants reloads your weapon, temporarily increases. Oh! You're approached by one of the cowled figures. Their fingers reach out and graze your armor with reverence. They speak musically, intently, and their rapid gestures imply urgency and concern. You gather that some scientists are in immediate danger and that your weapons are needed at the wildlife laboratory. The figure's hand touches your armor like a talisman as they beseech you for help. That's not creepy at all.
They're clearly very upset, and I don't blame them. Abduction is terrifying. I still haven't been able to suss out why talks with the exiles went south. I mean, these are poor circumstances for negotiation.
The readings on Kepler are still spiking. The singularity is still a threat. We'll need the Ionians' help if we want to open that lock.
I need to be doing this damage. What was that? I don't know what that was, but they shot it. Going vertical. Okay, where's this part? Conveniently in some odd spot. Get behind me. chair. Okay.
That's just as many researchers as the Emeritus said there would be. Didn't lose anyone. That's a relief.
I wonder if you might shed some light on something while we're still learning the language. This settlement is obviously well established, over decades, if not centuries, but I see little in the way of weapon emplacements or true fortifications. Has there been no conflict all that time?
That's the gist I'm getting. The Vex are new, and the Elixni, well, they used to have a working trade relationship. Armed conflict is new for the locals.
I don't know if this one's unlocked yet. Guess not. Any goodies back here? Any goodies I can open back here? Nope. Ooh, heavy ammo. Need some of that. Y'all too noisy. Turn it down. Command thanks the Golden Ratio for your safe return. Singularity remains stalled, and no Ionian was harmed. Emeritus clasps your hand in thanks. They added something about food. Your shirt's food, but the overall tone of the conversation does not seem to be about dinner. Very soon they have forwarded you some location coordinates. They want you to save their agricultural center from an attack.
You got my favorite thank you! Nice work, Guardian. You reunited the Ionians with their loved ones.
The scale of this problem concerns me. Our forces aren't so robust as to defend this whole settlement indefinitely. And defense is fruitless if we can't stabilize the singularity. We just discovered a lost colony. This discovery changes how we see our own system. How many others are out there?
Okay, how are we doing for time? I still got some. So yes, we will fix your agricultural problems. First, ooh. Yeah, store that, store that. Ah, here we go. Rainfall Anthem vest. That's not what I wanted. Let's see what this has. Refinable throughout. Gain sprint. Eh. Winter. Okay. Man, that thing's got some kick to it. Oh, this looks official. What are those? Okay. That's new and not nice. Imp swarm? Bring your raid, guys.
Guardian, you've got an incoming call.
You've made great strides in communicating with the Ionians. We've learned their language has multiple origins. Little wonder it needs such effort. Understanding comes not a moment too soon. Between the Elixni and the Vex, the situation here is unstable. And we have so much to learn from them. I followed your example in translating. Script first, then words. These notes you recovered. Unbelievable. The advances this outlines in gravitational manipulation, without the light. And that's only one thesis. I hope some of them at least will be amenable to returning to Earth. We cannot lose this connection. We simply can't.
No, it's a significant thing if they've got technology they've developed without the light. Okay. One of these things is not like the others. One of these things doesn't belong. That's a fucking train car in space. And it's another one. Go to the Agriculture Center at the Ionian campus to eliminate the Vex sabotaging last stable food production on Kepler. Oh, please be something that's not, like, algae-based.
The destructive activity in the agricultural zone is reading as Vex. They're the ones attacking the food supply.
Stop me if this one is obvious, but do Vex need to eat?
Not in any fashion we'd recognize.
Sounds like an empty life. Then this is just sabotage against the Ionians.
As if they weren't facing enough. The Nine, the Vex, and a singularity ripping the planet apart. That's too obvious a coincidence to ignore.
The Nine what?
Simply the Nine. They exist outside of time as far as we understand it. Difficult to confirm on the best of days.
Okay, where do I need to go? Yeah, I'm not liking these new imp things.
That Vex looks like it's protecting something. Guardian, watch out.
Okay. Have a matter spark. Zip under the floor. Avoid the electro goop.
The Vex tended to just let me pass on by before you showed up.
Excuse me? The Vex ignored you.
Guess they didn't see me as a threat. What can I say? I have a friendly face.
Lodi, how are you so adept with the Ionians' language? You said you've been here a few weeks at best.
Oh, I was made for this. I'm a translator. I especially love languages I've never heard before.
Oh, bad place to teleport, dude. But I guess touche. Fertilizer? Really? Oh, crap.
There's the Vex.
Could have rallied. Okay, this is new and interesting. Okay, we'll go this way.
I hate it when they do that. Guardian, let's redirect and get that shield down.
Ow, ow, ow. Ow. Devastator mine. That's new. Oop, oop, oop. Ooh. Oh, not vulnerable yet. Okay. It's a window. Okay, where am I supposed to be going? It's a window. There's also a window. This is where it came from. That's a thing. Oh, is that? Oh. What am I missing? What? Immune. Nope. Okay, I'm sensing some bullshit going on here. Sensing some bullshit going on there.
There's the Vex. hate it when they do that. Guardian, let's redirect and get that shield down.
Oh. Dirt. Come on, get down there. Here, take that.
Guardian, we should take a scan of that drive. See if there's any data stuck offline the Ionians need.
Messy.
It's incredible. Terms I recognize mapped to advanced concepts, prefixes and suffixes as used in agricultural science. We can use this. Let me do some analyzing, but this is a huge missing piece to understanding the Ionians.
Under the circumstances, what keeps the Ionians here? We could begin evacuation proceedings. They would be safe back on Earth.
But they wouldn't be home. They could take a piece of Kepler with them, sure, but it's not the same.
Homes can be replaced, but lives can't.
The Ionians might feel differently about that. This place is sacred to them. The universe determined they belong here. Singularity or not, we can't tell people to pack up and leave yet. Not without helping people who've been stranded from the rest of humanity.
Agreed. No one's leaving until we learn more.
Books.
Lodi, those Vex, you need to know who controls them. Her name is Maya, the conductor. She was human once.
What's her objective?
On the surface, to return our current time to a more prosperous one. But her true motive is to reunite with her spouse.
Neither of those sound particularly sinister, but I take it it's what she's willing to do to achieve that goal.
Maya has an ability. She can control whoever she pleases. She's commanding the Vex, a normally leaderless faction. She's even taken hold of our allies to turn them against us. If she's here, she can do anything to get what she wants.
Finally, some moments of peace. Thank you for your assistance, Anomaly Blessed. Anomaly Blessed. Strangelet capsule is almost certainly near. Before all of this, we built the lock as an altar. The vital ritual has been sealed from us. But it is living without our practice truly living? But is living without our practice truly living? The altar of relativity led to a place where it was easiest to detect the holy anomaly. We would even bring our exile friends with us to worship. Please, Anomaly Blessed, pass through and stabilize our holy site. Okay. Oh, I don't gotta go that far. Anomaly Blessed. I have an urgent request of you. The exiles have occupied our holy progenitor ship. The energy readings match hazardous explosive material. The ship's remnants still have fuel cells. If they explode, it could vaporize the settlement. Why is the Archon making things worse? Well, probably because he's a dipshit Lexney. It is an inflammatory attack by a friend lost in madness. He urges the singularity onward and lights fires to encourage the flames to rise. We all would prefer not to sublimate. Go now, please. Well, yeah, not sublimating is probably a good thing.
I know. The exiles have gotten into the, progenitor ship.
It's the remnants of the colony ship they arrived in. Any vibrational disruption could dislodge the lock and speed the singularity's growth.
We better move fast. Someone once told me that a shuttle quarter that size could go up like a bomb.
Ostos. Okay, one more mission. Luxney from House of Giles plans to destroy the structural history of the Ionians and most of the campus with it. Stop them before it's too late. Activity power disabled. Okay. Yeah, I can mulch that service revolver into blast right. Material observation can get mulched into Mira.
The ship the Elixir you've taken over. You're saying it's the very one the Ionians came here in?
Part of it anyway, what's left. They converted it to a permanent emplacement, but they still call it the progenitor ship. The mother of the Ionians. It's the source of all their tools. They put a little piece in every building. Every scientist gets a shot at the hull when they graduate. If the ship goes up, there's a lot the Ionians can't do. Do you have any experience with bomb disposal?
We've handled plenty of mines before. This shouldn't be a problem.
Style of ship is quite old. Even with only this much left, it's incredible. I haven't seen anything like it. The material could have been affected by the time anomaly here. That could account for the relatively good condition.
As a frame of reference, how old would you say it is compared to your ships?
Easily hundreds of years.
Oh.
Just how far away am I from completing? Okay, I have completed that. Yeah, why mess with a good thing? Gotten pretty good with this current build. No sense mucking around with it.
That equipment sure looks elixir. Let's see if we can tease it through. Hey, Silent Captain? We must be doing some real damage if they're deploying like this.
Can't touch this. Okay, how do I get this thing? Okay. Oh, in charge modes.
Guardian, the mines. If even one of them goes off, it threatens the entire material supply for the settlement.
Ah, crap. Right. Well, maybe I will give stock or another run. Yeah. See how we do with this.
That equipment sure looks elixir. Let's see if we can tease it free. An exiled captain? We must be doing some real damage if they're deploying like this.
Mines. If even one of them goes off, it threatens the entire material supply for the settlement.
Ah, pocket. because this is not the right one to be running. I need already 101, so I may as well throw that into I want to put it into class. Push my class up over 100. But still want more grenade. Harmonic resistance is probably not bad. Yeah. Ah, crumbs. Harmonic resistance. And percussion dampener. Oh yeah, gotta get the drip right too. Air of fair. Eh. That's sharp, but like this. Okay.
That equipment sure looks elixir. Let's see if we can tease it free. We must be doing some real damage if they're deploying like this.
he go?
Guardian, the mines. If even one of them goes off, it threatens the entire material supply for the settlement.
Crap. Another pocket. Okay, screw it. Going back to... Do I want to run Thread Runner? Oh yeah, right. This is my... Sick deals me double grenades. Northern Maelstrom is fun. Or woven mail. Red lines travel farther. Damage. Grenade reloads weapon. Weapon on the mail gives tangles. Healing damage generates grenade energy. Okay, and fortunately, I need something red related. Yeah, Alice. Really, I don't have a lot for heavy red weapons. Pro Memorial looks probably the best. I wonder if I replace that. Oh, nice. Those are micro rockets. MPA regulator. So sustained fire and yep. Yeah, that's a good one. I'm running that pistol. Fucking oh. That'd be good. Ah, crap. Okay, let's try this one more time.
That equipment sure looks elixir. Let's see if we can tease it free.
Ah.
An exile captain? They must be doing some real damage if they're deploying like this.
Guardian, the mines. If even one of them goes off, it threatens the entire material supply for the settlement.
Ah, crap. Frick, I hate those things.
That equipment sure looks elixir. Let's see if we can piece it through. Exiled captain? We must be doing some real damage if they're deploying like this.
Guardian, the mines. If even one of them goes off, it threatens the entire material supply for the settlement.
Okay.
No more anomalous energy signatures. Good work, Guardian. The Ionians are safe because of you.
We haven't put a scratch on the House of Exile. The Ionians say the Archon's only out to speed up the Singularity's growth. He's just going to throw more gas on the fire.
The Guardian will be able to stabilize the Singularity once we get through. There are too many problems, and all of them are connected.
You have no idea.
Unless you have any ideas, then we have to consider evacuation. Reunification with humanity. After centuries apart.
Centuries? No. No, them coming to Earth would be existentially disorienting.
Lodi, please don't mistake me. This is the Ionians' home. We have to believe there's a way for them to return safely.
And what if there isn't?
Oh, well. Extinction or loss of home. That is the choice. And with that, ladies and gentlebots, I am going to have to call it a night. Thank you everyone for coming. It's been an interesting night. A lot of new followers, a lot of new spam. VODs will be up sometime this weekend, hopefully. So once again, thank you for coming and watching the stream. My name is MachinistM, and I wish you all a good night, and Imantibus ad Astra. See you among the stars.